Hello guys, you're welcome to Vince Tech class. And in today's tutorial, I'm going to walk you through the MNIST digit classification using TensorFlow. The MNIST dataset is a widely used dataset consisting of handwritten digits from 0 to 9. The task is to classify these digits into their respective categories. We start by importing the required libraries, mainly TensorFlow and other utilities. We import TensorFlow as TF. From TensorFlow.keras.dataset, we import the MNIST. From TensorFlow.keras.model, we import sequential. And from TensorFlow.keras.layers, we import dense and flattened. Next, we load the MNIST dataset. We have the training images, we have the training labels, we have the testing images, and we have the testing labels. Next, we normalize the pixels values to the range of 0 to 1 by dividing it with 255 for the training images and 255 for the testing images. It's just part of data preprocessing, especially when you're dealing with image in computer vision. Next, we build our model. We build our model by creating a sequential model using the TensorFlow sequential class. Then we add layers like flattened to reshape the data and dense layers for neural network architecture. Let me move down a bit so that you understand what I'm explaining. This is the flattened. Flattened the 28 by 28 images into one-dimensional array. We also have the fully connected layer with 128 neurons and ReLU activation. And finally, we have the output layer with 10 neurons, one for each digit, and softmax activation. That is the digits from 0 to 9. Next, we compile the model. We use the Adam optimizer. For the loss, we use the sparse categorical cross entropy. For the metrics, we use accuracy. Next, we feed the model to the training data and specify the number of epochs. We have about, in one case, we have 10 number of epochs. That is how many times the model will go through your data to learn. And after 10 epochs, we have our accuracy to be 99.5 and a loss of 0.0162. Next, we evaluate the model's performance on the test dataset, which gave us an accuracy of about 97.5, or let's say 97.6, to show that the model is performing well. And also, there's a point worthy of note. Just bear in mind that this is just a basic outline for MNIST digit classification using the TensorFlow. You can further fine-tune the model, experiment with different architectures, or use techniques like data augmentation to improve the performance. And also remember to install the TensorFlow if you have not installed it. So guys, that's all for today's tutorial. If you have any question, leave them in the comment section below, and don't forget to like and subscribe to my YouTube channel. Thank you.